this video, we're going to be looking at graphing a quadratic function again. I've made a previous video about this, but we were looking at standard form. Now we're going to look at vertex form. All right, so the first question I always get is, why the heck do we have two forms? Well, vertex form actually shows us the vertex, so the ordered pair for the vertex, rather than us having to find it. And once again, you can go back to the standard form video and take a look at that. So that video is actually more work because, once again, the good thing about vertex form is it actually gives us the vertex. So first let's look at what vertex form is. So here's how it looks. So we say f of x equals a times x minus h squared plus k. Now, every year this kind of happens, or every time I teach this, a lot of people are saying, well, what the heck is h and k? Like, how did that get thrown into the mix? All right, so let's actually look at what each of these mean. Let's start with h and k, actually. The vertex is actually h, comma, k. So whatever this number is here in this parentheses, and whatever this is on the outside when it's added or subtracted, that tells us the vertex. But just make a quick observation that this was minus h, and when we took it out for the vertex, we actually flipped the sign. So you're going to have to do that every time with vertex form. So you have to make sure you remember, flip that sign for h when you bring it out of the parentheses. All right, we'll practice that in a second. So that's the first part. The second part is this. This a in the middle actually tells us the same thing that it told us in standard form. If that a is positive, that means my graph is going to open up, and it's also going to tell me that I have a maximum value, or actually I have that backwards. It's going to be a minimum value. So it's going to look like this. It's going to be concave up. All right. Now, if that a is negative, then that means it's going to be concave down, which would look like this. Once again, it opens downward. And then that would tell us we have a maximum value. So the good thing about vertex form, once again, is this vertex. But this a that's going to be multiplied in front also tells you the same thing that a from the past told you. So let's actually look at a problem so that we can kind of dive into how this works. So here is our first f of x. We'll say f of x equals x minus 2 squared plus 3. Now, first of all, let's just kind of observe this and look at this. There's a 1 understood to be in front of this parenthesis, so that'd be a positive 1. So right now we're saying a is positive, which tells me my graph should open up, which also tells me I have a minimum value. So that's just to get a visual that this should open up and give me a minimum value. So let's see if that actually happens. Now, once again, my vertex, I don't need to find the axis of symmetry or anything like that. I can just use what's in the parentheses here and what's added on the outside here. That tells me h and k. The only thing you have to remember about h is when h comes out of the parentheses, it actually switches its sign. So instead of my h being negative 2, it's positive 2. And then 3 is going to be k. So that's my vertex. So I go to 2, 3, and I graph my vertex. Now, the easiest way to do this next part is to make yourself an x and y table, just like we did in standard form. And just like in standard form, you're going to put the vertex in the middle of your graph because you want your table to center around this vertex. So your x values, you're going to take 2x values, and actually, let's get rid of some of this stuff. Let's move some of this out of the way. There we go. All right. Yeah, let's get rid of the vertex. I think we're all good. We know what the vertex is. So let's just do this. All right. So now, once again, 2, 3 is going to go in the middle. So now, when you look at your x values, you want 2x values to the left of 2. So that would be 1 and 0. And then you want 2 values to the right of 2, which would be 3 and 4. Now, the good thing for you is, if you find 2 lower than 2 or 2 higher than 2, they're going to be the exact same because a parabola is reflected, or not reflected, geez. A parabola is symmetrical. So that means if I were to draw a parabola, I could split it down the middle and it's going to be equal on both sides. So the good thing about that is I only really need to plug these two in. So I need to see what is y, or what's my f of x, when x is equal to 0. So that would give me negative 2 squared plus 3. Negative 2 squared is 4, plus 3 is going to give me 7. Now, when I find out that 0 equals 7, because this is symmetrical, I actually just figured out that 4 is equal to 7. All right, now let's do 1. So let's plug in 1. Let's see, we said this is 7, this is 7. So now let's plug in 1 in for x. And once again, when we know 1, we'll also know 3. So we're going to say 1 minus 2, that would just be negative 1. So we're going to say negative 1 squared plus 3. That would be positive 1 plus 3, so that would be 4. Now, if 1 is 4, then 3 is also 4, because once again, this is symmetrical. So, let's, what did we say this was? 4. We said this was 4. All right. So now, once again, our parabola is going to be symmetrical, and it's going to start at 2, 3. So 2, 3 is going to be right here. And then our points that we just found are, let's see, we have 0, 7. So 0, 1, 2, 3, 4, 5, 6, 7. We also know that 4, 7 is going to be pretty much in the same spot. But now the x value for that's going to be 4. 1, 2, 3, 4. Okay. So those are 2 points. And then we can make 2 more. We can do these 2. So 1, 4 is going to be right here. 1, 2, 3, 4. And then let's see, 3, 4 would be in the same spot, but now it would be at x equals 3. So then our graph actually looks like this. It opens up. My drawing is actually pretty bad when it comes to this. That's about as good as I can do. All right, so if you remember, we said this should open up and it should have a minimum. That's exactly what happened. So let's do another one just to get an idea of it. And if I were you, I would try this one on my own just to get an idea for practicing it, but I'll also go through it too. So let's say f of x equals negative 3 times x minus 4 squared plus 1. So the first thing we want to do, we don't have to do this, but I just want to make a note of it for you. This number that's multiplied in front, that's a. If that number is negative, that means that we're going to open this parabola downward, which means we will end up having a maximum value. It's going to look something like this. Not exactly like this, but it'll look something like that. All right, now, all that's kind of added information, so let's go to the actual main part, which is we want the vertex. And the good thing about vertex form, it gives us the vertex. It's going to be this and this. That tells us h and k. Just remember, when you find h, flip the sign. So this is actually 4, 1. That is my vertex. All right. So now let me get rid of some of this. I can get rid of the vertex too. So we'll say now we're going to take that vertex and we're going to put it into an x and y table, but we're going to put it in the middle of our x and y table because we want our graph to center around that x and y value. We said it was 4, 1. So now we're going to go to our x values, and we're going to say I need 2 values to the left of 4, which would be 3 and 2, and then 2 values to the right, which would be 5 and 6. And once again, I just want to make you aware of this. When I find 2 and 3, I'm actually going to know 5 and 6 because this is symmetrical. So let's plug in 2 first. If I plug in 2 for x, let's see, negative 3 times, let's see, 2 minus 4 would be negative 2 squared plus 1. So that would be 4 times negative 3 plus 1. So that's going to be negative 12 plus 1, which is negative 11. All right, so 2 is negative 11. And here's the good thing for us. If 2 is negative 11, then that means 6 is also negative 11. All right, now let's plug in 3. We're going to get negative 3 times negative 1 squared plus 1. Actually, that was kind of poor writing on my part. I wrote it right into the graph. All right, so negative 3, negative 1 squared plus 1. That would give me negative 3 plus 1. So it should be Should be 2, negative 2. There we go, negative 2. All right, so now if 3 is negative 2, that means 5 is also negative 2. All right, so let's get rid of this. All right, actually I didn't even need to get rid of all that. All right, so here we go. Now we're going to start off at 4, 1. So 4, 1 is right. 1, 2, 3, 4, 1 is right here. Now remember what we said at the beginning. This should open downward, so let's see if that happens. So our next 2 points are going to be 3, negative 2, and 5, negative 2. So 1, 2, 3, negative 2 is right here. 1, 2, so 5, negative 2 is right here. Now on my graph, I actually don't have room for negative 11, but you know that 2, negative 11 is somewhere down here, and 6, negative 11 somewhere down here. So if we connect all that, it does make sense that this opens downward, which I'm not even close. All right, let's see. I'm going to spend more time actually trying to draw these graphs. Okay, I give up. All right, so that's how our graph is going to look. So once again, vertex form is really nice because it gives you the vertex. And then you can use an X and Y table and figure out the points that are around that vertex, and then you're pretty much good to go. But keep in mind that A is going to actually tell you a lot of useful information. A is going to tell you when there's a maximum, a minimum, concave up, concave down, all that good stuff.